Integral for radical 5x squared minus 9 over x dx. So we have a square root and x squared, then it's a trigonometric substitution. Just a note, in trigonometric substitution the coefficient of x squared is always 1. Here also. So in our case the coefficient here is 5, so we need to take out this 5 outside the square root. So it's equal to integral radical, take 5 common, x squared minus 9 over 5 dx over x. Now let's take this 5 outside the integral. So radical 5 integral for radical x squared 9 over 5, we can write it as radical 9 over 5 all square. So minus radical 9 over 5 square dx over x. Now so we have x squared minus a squared, so we should take x equal to a secant theta. So x equal a secant theta, and a is equal to radical 9 over 5 secant theta equal to 3 over radical 5 secant theta. Let's find the x. So derive both sides. 3 over radical 5, derivative of secant is secant tangent, equal radical 5 integral for radical x squared is 9 over 5 secant square theta minus radical 9 over 5 is square is 9 over 5 dx 3 over radical 5 secant theta tangent theta d theta over x 3 over radical 5 secant theta. Now 3 over radical 5 drop 3 over radical 5 and secant theta drop secant theta, so we will have radical 5 integral for radical. Let's look at this one. If we take 9 over 5 common factor, so 9 over 5 secant square theta minus 1. But secant square minus 1 is equal to tangent square. So 9 over 5 tangent square theta, and we have radical 9 over 5 is 3 over radical 5, and radical tangent square is tangent theta. So we can remove this square root and write 3 over radical 5 tangent theta times tangent theta d theta. Radical 5 drop radical 5 equal integral for 3 tangent square theta d theta. We don't know the integral of tangent square, but tangent square is equal to secant square theta minus 1. And we know the integral of secant square, it's equal to tangent theta. So we will have 3 integral for secant square is tangent minus theta plus c. And the last step is to write the integral in terms of x. Here it's in terms of theta. So let's look at the substitution. We took x equal to 3 over radical 5 secant theta. So x equal to 3 over radical 5 secant theta. So secant theta equal, multiply both sides by radical 5 over 3. It will be equal to radical 5x over 3. Now let's look at the right triangle. Suppose that this is theta. In this triangle we know sine, cosine and tangent, so it's better to transform secant to cosine. We know that secant is equal to 1 over cosine theta. So in this case, cosine theta will be equal to 3 over radical 5x. And cosine theta is equal to adjacent side over the hypotenuse. The adjacent side is this one, so it's equal to 3. And the hypotenuse is radical 5x. So, to find theta first, it's equal to cosine inverse of 3 over radical 5. So we have here 3. Theta is cosine inverse of 3 over radical 5x. Now we need to find tangent. We know that tangent theta is equal to opposite, so this side, over the adjacent side. The opposite side, according to Pythagoras' theorem, is radical hypotenuse square, so radical 5x square minus this side 9. So this side is equal to radical 5x square minus 9, and the adjacent side to theta is 3. So this is tangent theta. So 3 times radical 5x square minus 9 over 3. Let's multiply 3 by 3, drop each other, so equal to radical 5x square minus 9. Here we have minus cosine inverse of 3 over radical 5x over 3, or times 1 over 3 here, plus C, and it's done. If you like the video, please hit the like and subscribe button. Goodbye.